Hey there, and welcome back. So, now we are starting to learn a lot of the basics, the building blocks that we need to use when we're programming in assembly language. But there's still quite a lot of things we need to learn. So, first of all, let's take a look at what we have learned so far. We've talked about the CPU and the RAM and briefly talked a little bit about hardware. So we know that when we're programming in assembly language, we're programming directly towards the hardware, and that's what makes this special compared to other modern programming languages like Java, Visual Basic, and so on. So we're programming towards hardware. And we also looked at we have also looked at a few mnemonics here: LDA, STA, LDX, STX, INC, DEC, and so on. So we have already looked at quite a few of these. We haven't looked at everyone, all of those, but we have looked at a few. We're going to look at a few more today. So yeah. We've also talked about constants. A constant is just a friendly name for a number that can never change. We have talked about variables, a friendly name for a memory address. And of course, variables can change. And we also talked about tables last time, which is kind of the same thing, but instead of having a label for one memory address, we have a label for one memory address, but we have this X or Y index, which allows us to have several values after that label. So we can have a table with several entries. And also we know that tables can be created in ROM or in RAM. If we need to change values in there, we put them in RAM. We also looked at how we can do that in NESmaker. So these are briefly the things we've been talking about. But we haven't talked about programming logic. So what we've learned so far, we can't use that to create advanced programs because we have no way to create decisions. So for example, if you have programmed in Java, Visual Basic, or whatever, you know that we have these decision commands, if you want. If, then, else, for example. If x equals 2, then do something. Else, do something else. So we have to have a way to decide, based on certain conditions, what we want to do in our code. Because if we don't have that, then the code is going to do exactly the same all the time. And in our case, that would mean that it wouldn't be a game. We couldn't do anything there. So we need to have a way to decide what's going to happen based on certain conditions. We're going to have to come back to that. And also loops. If you programmed in other languages, you know that you have something like do while loops or for next loops or whatever. While x is less than 10, then do something. Now, we need to have a way to do that as well in assembly language. So we need to talk about these two things today and how we can do stuff like that in assembly language. So, we're talking about programming logic. And as you can see, or as you probably understand, it works a little differently in assembly language compared to these modern languages. Because we don't have if, else, while, those sort of commands. We just have these three-letter commands called mnemonics. LDA, STA, that sort of thing. So, we're talking about branching, looping, and jumping, and we're talking about assembly language. So let's start with the easiest of these, which is jumping. let's look at how we can jump in assembly language and what that actually means. So first of all, we've been talking about labels. We have these labels. Now labels, that's just a friendly name for a memory address. Now so far we've been using these labels if we want to make a variable, for example. So we could have said my health there, and that would mean this memory address. And of course then, and if this was a variable, it would have to be in RAM, of course. But the point here is that we have these labels, and they're nothing special. They're just a friendly name for a memory address, and it's up to you what you want to do with that. So I just made two labels here. Handle player hurt, that means this memory address, 8500. Then I have another one down here, skip player hurt, that's also a label, and this label means 8508. So the point here is that we have these labels, and they're not just used for variables or tables. We use them however we see fit. Now we're gonna have to look at how we can do that in a sensible way. So let's look at an example. Let's look at the monster hurt script. Now this is a little custom one. It's not 100% default NESmaker. But let's look at this one. Now, first of all, there's a lot of code here, so don't worry about all this code. Don't get overwhelmed by this. What I want you to focus on right now is this jump thing. So the point with this jump mnemonic is that it lets us jump to wherever we want in our code. And I'm jumping to this label here, and we write JMP. That's the mnemonic, and of course it means jump. So jump to skip hurting this monster. When I write that in my code, I'm just gonna go there. I don't do any checks, I don't do anything like that. I just, whenever it says jump, just go to that place in the code immediately. No more fuss, no nothing. We just jump straight there. Which basically means in this case, and write that here, we're going to skip whatever comes after that because we're moving directly down here. Now normally how the program works, it would just do one line after the other, but if it comes across a jump, then it just jumps down here. Same thing if we get down here, jump, skip hurting this monster, then I'm gonna jump to the same label down here. So jumping is really simple, it's nothing complex. We're just jumping to a certain part of the code, which of course means we're gonna skip whatever comes below it here. So we're just jumping to a different part of the code. So if we want to get a little technical, basically jumping means jumping to a different part of the memory. Maybe a little complex way of thinking about it, but that's what happens. You're just jumping to a different place in the code. And there's no limit to how far we can jump in the code. We can jump anywhere we want in the code. But we have to be a little careful. We must be careful not to jump all over the place like it says here. Meaning, let's say you have 5,000 lines of code. Like in NESmaker, for example, there's a lot of code in NESmaker. We shouldn't be jumping all over the place. There's a lot of code files and hundreds or thousands of lines of code. So we can't just jump all over the place because that's going to have consequences. So especially now in the beginning, it's probably best just to jump a short distance. So you have control of what you're jumping over. You don't want to jump skip an important part of the NESmaker code, and it's going to crash our game. So you have to be a little bit careful about that. But don't worry, we're going to look at a few examples that's going to help us do that. So that's jumping. Jumping is really simple. We just jump to a different part of the code, and there's no limit to how far we can jump. No technical limit anyway. But what about branching? Well, branching is kinda similar to jumping, but there's an important difference. Let's look at this monster herd script. Now again, don't worry too much about all the code. Let's just look at how this branching thing works. So, sorry, here I'm saying branch if not equal. We're gonna look at the mnemonics in just a second. But I say branch if not equal monster herd. Basically, the point here is that I'm still moving to a different part of the code. Same thing here. Branch if equal, destroy monster. I'm moving to this part of the code. Now the main difference between branching and jumping is that when we're branching like this, we're branching under certain conditions. When we're jumping, we don't care. We just jump wherever we want. We don't do any checks when we jump. When we're branching only under certain conditions. And this makes it more similar to what we were talking about in the beginning, if else in other programming languages. In this case, we're only branching under certain conditions. So before we continue, let's look at the mnemonics, the branch mnemonics. So the first three mnemonics here are not exactly branch mnemonics, but they are going to help us. Let's just look at this example up here in the corner for how we would do this. I could write something like LDA my health, so load A with the variable my health, and then CMP. Now as we can see here, CMP, that means compare. But since I'm using LDA, the accumulator, I need to use this one. This one is used with the accumulator. If I were to write LDX or LDY instead, then I would have to use CPX or CPY to compare those values. But I'm using LDA, so I'm using CMP, compare. So LDA my health, I'm loading A with my health. Then I'm comparing it to the number 8. CMP compare. So I'm comparing this value to the number 8. Then I say branch if equal. If these two numbers are equal, then branch to this label, player has max health. Now, what if those numbers are not equal? So I'm loading A with my health, and let's say it was 5. Load A with my health, which is 5, compare that to 8, branch if equal, but they're not equal. So if they're not equal, then we just continue on here on the next line, and we do whatever it says in here. So we're only branch if equal, we only branch if those values are equal. BEQ, branch if equal. So we have a few of these branching mnemonics. BEQ, branch if equal. Then we have BNE, branch if not equal. So let's imagine that I wrote BNE here instead of BEQ. So then I would say load A with my health, compare that, let's say my health was 5, so I'm comparing 5 to 8, branch if not equal. Well, 5 and 8, no, they're not equal. Well, if they're not equal and I use BNE, then I branch to that label. So this checks if the numbers are not equal. All right, then we branch. If that condition is not true, then we just continue on like we saw with the BEQ. So we're branching to labels based on certain conditions. And we have a few more. Let's look at this one. BCC, branch if carry clear. That sounds kind of complicated. What it means is branch if less than. BCC is branch if less than. So if I wrote BCC here, I could say load A with my health, and my health is 5. Comparing that to 8, BCC, branch if less than. Well, 5 is less than 8. BCC, yeah, sure, it's less than, so then I'm going to branch. So in this case, I'm going to branch if this first number is less than the number we're comparing it to. And we also have this one, BCS, branch if carry set. Again, it sounds complicated, but this one means, and it's not quite what you would think, because it's not just greater than, but it's equal or greater than. So BCS checks if it's equal or greater than. So we need to be careful about that. So if we use BCS here, we could say load my health. My health was 8. So I'm loading 8, comparing it to 8, and let's say I'm using BCS. Well, BCS is equal or greater than. 8 is equal to 8. So in that case, I would branch. If I load my health and my health is 11, my health is 11, I'm comparing that to 8. BCS equal or greater than. Well, in that case, I would also branch, because 11 is greater than 8. So again, these things are probably things you need to practice a little bit, because just looking at them like this, maybe you understand how they work, but it's easy to forget how these different things work. Especially this one, which is not just greater than, but equal or greater than. We have a few more. We have one called BMI, branch if minus, BPL, branch if plus. I don't want to look too much at these, because I don't want to talk a lot about negative numbers, because negative numbers is really confusing, and you don't need to get confused here when we start learning assembly language, and you don't really need to know too much about those. But let's just look at this one just as a brief example. Branch if minus. Let's say you're loading A with 2. So you have 2 in A now, but you're subtracting with 5. Now 5 minus 2, that's a negative number, minus 3. So in that case, if we want to check for stuff like that, we could use BMI, branch if minus. Branch if plus, if it's not minus. Now let's not go too deep into those two. The point here is that we have these helper mnemonics, CMP, compare, which we're using with the accumulator. If we load X or load Y, we want to compare those values, then we write CPX to compare whatever's in the X register, or CPY to compare with whatever's in the Y register. Okay, so the point here is that we have these different mnemonics to branch. We branch in different ways. All right. So let's look at this example. Very simple example. Here I'm loading A with my variable. Now right now there's a 7 in my variable. So I'm loading A with 7 because that's what's in there. And then I'm comparing it to 10. Compare 7 to 10. Branch if equal my label 1. well, 7 is not equal to 10, so I'm not going to branch there. What happens then? Well, in that case, if that condition is not true, then I just continue on here to the next line. And here it says JMP, my label 2. Alright, well, jump command doesn't check for anything, so then we just jump down here. So that's a very simple example of how we're comparing and branching. Loading A with something, comparing it with something, and then we say, in this case, branch if equal. So if those two numbers are equal, then we go here. But we only go there if those two numbers are equal. If they're not equal, we just continue on here. And in this case, there was a jump in here, so shoo, I just go down here. Very simple example. But let's look at a more real example. Let's look at a pickup script, for example. How could we do stuff like this in a pickup script? Well, let's take a look. So here's an example of a pickup script in NESmaker. First of all, let's just remember in NESmaker that we have these object type numbers starting from 0 here on the top. So the player object is object number 0, then the next one is object 1 and 2 and 3, so on. So here the health pickup is object type 4. That's the case with default NESmaker as well. So health pickup, this object is object type 4. Alright. So here in my pickup script, I start by saying LDA object type comma X. Now what's this object type? Well, we know that when we write comma X like this is basically what we call a table. Also, let me just explain very briefly something about how NESmaker works. So whenever you see something like this, comma X in NESmaker, oftentimes that means the active object, the object that's active right now. Now, what does that mean? Well, try to think about it this way. There's a lot of code in NESmaker, a ton of code. And basically, it's just a huge loop, and it goes over and over and over again, performing a lot of code. Now, for some of that code, like the physics script or the hurt script, or, whatever, collision scripts or stuff like that, in those types of scripts, we can think of it this way, that each active object gets their own turn through those code files. So first, it's the player object. We check the physics script so he can move. Then the player checks the collision scripts and stuff like that. And when he's done, if the player is done with all of those scripts, then we go to the next object, and it gets its own turn through those files, and then the next object, and so on. So that's how this stuff works. So when we see object type comma X, we don't, at this moment, when we're reading the code, we don't know exactly what object's in right now, because this changes constantly when the code is running. So we need to handle this in the code to make sure that we're dealing with the right object. In this case, I want to do something when an object is object type 4, health pickup. So whatever object's in here right now, I need to check, is this object type number 4, LDA object type comma X. Is whatever's in X right now, is that object type 4? Is this a health object? Because the pickup script is run when the player collides with a pickup object. Then this is run. So we're checking that other object. Is that a health pickup? So load object type comma X, compare with 4. branch if not equal. No, it's not object type 4. Okay, not this pickup, so we go down here and we skip that other code. But what if it is object type number 4? Load a object type comma x, compare with 4. Yeah, this is object type number 4. Alright, so we're not gonna go this is branch if not equal, right? But they are equal, so we just continue on here. Then we say LDA my health. Right now my health is 6. Then I'm comparing it to another variable called my max health. Now my max health right now is 8. So here I'm comparing 6 to 8. And then I say BCS, no more health. BCS, you remember what that is? Yep, branch if equal or greater than. BCS, branch if equal or greater than. So I'm comparing 6 to 8, branch if equal or greater than. Well, 6 is not equal or greater than 8. So I'm not going to be doing this, not going to be going down there, which means I just continue on to the next line, and here it says inc my health. So my health is going to go up by 1 right now. Then I just continue on to this one. Now remember, labels alone like this, they don't do anything. So we get to here, nothing happens, but then we get to here, jump and pickups. So now I get down here. So this is how we can use these different branching things in something like a pickup script, for example. Comparing and branching based on certain conditions. By the way, why am I using this? Branch if equal or greater than. Well, let's take a look at this now. I'm loading my health. I'm checking how much health I have. Comparing that to my max health. My max health is set to 8. That's the maximum health I can have. Why am I saying branch if equal or greater than? Well, think about it. What if my health was 8 right now? Comparing this to my max health, which means branch if equal or greater than. If my health was 8, then it would be equal. So then I would skip this. The reason I'm skipping it in that case, because I don't want to increase my health beyond the maximum health. I don't want to have 9, 10, 11, 12, 13 health is if my max health is 8. That's going to create problems for me. So oftentimes I create checks like this to avoid running into trouble later on. So the point I was trying to make here is just using an example from NESmaker and showing you how we use these different branching techniques, comparing and branching. And we have different branching techniques, as you know. Right, so let's look at another example, monster hurt script. Now again, we have a lot of code here, and by the way, to make this easier to understand, I changed the top line here. There's not a variable in NESmaker called action step. I just made that up for this example. The reason is, by default, it says get action step here. That's a macro. We haven't talked about macro, so I don't want to confuse you unnecessarily. So I just wrote LDA action step. So let's just imagine that action step is a thing. It's a thing where I keep my action steps. So here I'm saying load A with action step. Right now it's set to 1. And this is the monster hurt script. So which means the monster is in action step 1, he's walking around. Then I say compare whatever's in here to 7, which is the hurt state in NESmaker. So compare that to 7, branch if not equal. So that means that if the monster was in a hurt state he is in his hurt state right now. Then we can't hurt him again if he's already in the hurt state. But in this case, he's not in the hurt state. He's in action step 1. He's walking around, which means we can hurt him. Load A with action step 1. Compare that to 7. Alright? Branch if not equal. Well, 1 is not equal to 7, so yeah, we're gonna be branching here now. Hurt monster. What happens here? Well, we looked at deck, so we know what that means. Decrease a value in memory. In this case, we're decreasing a certain position in this table object health. Oh, let's not go into detail about that, about how that works right now. But we're decreasing the active object's health. Let's just put it that way. Decreasing that, but we decreased whatever was in memory over there. Now we need to bring it into the accumulator so we can check what the active number is now after decreasing it. Whoa, wait a second. What's this? There's no compare in here. Here I just say LDA and then go straight to BEQ. Didn't I just say that you need to use a compare like this? Well, let's go over here to this box over here. We don't need to write CMP 0. So whenever we're comparing with 0, we can just leave that compare. We can just avoid writing this one. So here I'm comparing with 0. Now you can write CMP 0 if you want in here, but it's unnecessary. Sometimes if you have a big confusing code, then maybe it's actually a good idea to do this. But usually you don't need to write compare with 0, or you never need to write compare with 0. You can do that, but you don't have to. So load A with object health, X, and then I go straight to BEQ. But what does that actually mean? Well, when I write it like this, I say BEQ. Well, that means branch if this is 0. BEQ branch if whatever's in here is 0 now. So I'm loading the object health for the active object that's in here right now. Is it 0? Well, if it is 0, branch if equal, branch if it is 0. Then we go down to destroy monster down here. But what if it's not 0? Well, then we continue on and we get to this next line that says BMI destroy monster. Now BMI, what was that? Okay, BMI is branch on minus. Is this one of these things that I didn't want to talk too much about? But let's put it this way. Here we are decreasing the health of the monster. Let's say instead of health going down by 1, let's say we have a huge weapon that's going to do 3 damage to the monster. If the monster just has 1 health and we're subtracting 3 from that, then we end up with -2. And that's a negative number. So, like I said, I don't want to go too deep into this, but that's why we have this. So, if this is what we call a negative number, then we're also going to branch down here. But if it's not 0, and if it's not a negative number, then we just continue on. And in this case, we're changing the action step for the monster to 7. And we're skip hurting this monster. So after changing the action step, we jump down here and we skip this code below. So I hope that makes sense. Again, I'm just trying to show you how we use these different branching techniques. We don't have if-else, as you know, so we need to branch based on different conditions. So, branching. we branch to a different place in the code based on certain conditions. But we haven't talked about this. We can only branch so far. If you remember the jump mnemonic we talked about a minute ago, we can jump wherever we want in the code. Technically, we can do that. There's no limitation for how far you can jump. But there's a limitation when it comes to branching. We can only branch 128 bytes. So if you look at this drawing down here, let's say we have a code here in the middle that says LDA something, compare with something, branch if equal to my label. Well, it doesn't matter if the my label is up here or down here. If the amount of code that we have between this and my label, like I said, doesn't matter if it's up here or down there, but if there's a ton of code between this compare and branch thing and my label, then we're gonna have a problem. We will get branch out of range error when we click export and test in NESmaker. So we can only branch so far. There's a limitation for how far we can branch. Now, finding out exactly how 128 bytes, how are we going to figure that out? Okay, so that's a little tricky. We don't usually count the bytes in our code. And the way we would do that, if we were to do that, would be something like, I don't know if you remember from earlier in this course, they talked about LDA. That can be 2 bytes, and these different mnemonics have a few bytes each. Usually 2-3 bytes, something like that. So basically how that works is that you add all that together to see how much space that's going to take. But that's way too technical. Definitely don't have to talk about that. But usually you'll just come across this branch out of range error. You'll just come across it when it happens. And it's okay. It's not gonna break your project, hopefully. So we just need to work around that. You need to find a solution for it. So you write a lot of code, you're really excited, you get stuff to work, and then you run into this branch out of range error. How can we fix that? Well, there's a workaround for that. Quite simple workaround, actually. So this is how to avoid branch out of range error. So first, let's look at the problem. Let's look at, let's say this was the monster hurt script. And I say LDA object health, x, branch if not equal, skip destroying this monster. So if the monster still has health, I don't want to destroy it. And branch if not equal, I don't have any compare, so I'm comparing with 0. Branch if not equal, this is not 0, so I want to go down here. The monster still has health left. But there's a problem. I have too much code in here. I have so much code in here where I'm doing all these fancy things to destroy the monster. Tons of explosions and sound effects and all kinds of stuff in here. So there's a lot of code here. All these dots, it's a ton of code. And it's over 128 bytes. All of this combined, it's a lot of code. Which means I can't branch like this. It's too far. I can't branch from here all the way down there. It's too far. So this branch will cause a branch out of range error. And by the way, you'll see that, like I said, when you click export and test, and you'll see in this black DOS prompt window that pops up. That's where you'll see this branch out of range error. So that's the problem. I can't branch that far. Alright, so how do I solve it? Let's look at the solution for that. So the way we solve this is really simple. we just reverse the logic here. So we reverse the logic from B and E to BEQ. So instead of branch if not equal, go down here. Instead of doing that, I say branch if equal, and then I add a new label called destroy this monster, and I just branch to that instead. So instead of saying branch if not equal, go down here, I'm changing that from branch if not equal to branch if equal. Create a new label that I can branch to, because that's right below, so it's no problem at all. But in order to handle that, if the monster still has health, because here branch if equal comparing to 0, so I'm saying if the monster health is 0, then go here to destroy it. But if it's not 0, then I just continue on here, and here it says jump, skip destroying this monster. So now I can jump down here, and as you know, we can jump as far as we want. There's no limitation for jumping. So add a jump here, reverse this logic, create a new label, and I squeeze a jump in there. So I can't skip this. In this case, we're checking if the monster health is 0 or not. So we have to deal with both of those conditions. If the monster health is 0, then we just go here. If it's not 0, then we skip destroying this monster and we go down here. So I hope that makes sense. That's just how we do a workaround. So let's compare this to how it was before. This is how we solved it. This is how it was. So here I just said branch if not equal, and I want to branch all the way down here. Well, that doesn't work because there's a lot of code, so I do this instead. This little workaround. Problem, solution. So, like I said, I hope that makes sense. Alright, so I think we talked enough about branching. Let's talk about something else now. Looping. If you've programmed in other languages, you know what we're talking about here. Do, while, for, next, and so on. We're going to take a quick look at looping. We're not going to go into detail here. But the definition of looping is doing something a certain number of times. So doing a certain part of the code a certain number of times. So how can we do that in assembly language when we don't have while, next, for, whatever? Well, we do it this way. This is an example loop. We need to use the X or the Y register. We can use both. They work the same in this case. So here I say load X with 0. Starting out by loading X with 0. Then I create a label called my loop. Of course, it could be whatever you want. So the first thing I do here under my label is I do something very cool. In other words, I have some code that I need to perform in here. So once I've performed all that code, then I say increase X by 1. So now X goes up from 0 to 1. And then I say compare whatever's in X now to 10. Is X 10? Well, no, it just went up from 0 to 1. So it's not 10 yet. Alright, so if those are not equal, branch if not equal, my loop. Then I go up here again. So I'm using this compare and branch thing here as well. I'm using those to create a loop. Why am I comparing X to 10 here? Well, that's to make sure that the loop runs 10 times. So here I just specify how many times I want this loop to iterate. So that's a very simple example of how we make a loop. Just using the X or the Y register, starting out maybe with 0, how you construct this loop is really up to you. Depends on what you're trying to do, of course. But you start with a certain number and you go up to a certain number. Or you could go down as well, but let's not go into that. So anyway, that's a very simple example. But let's look at a little more complex example. This is the example, destroy all monsters. So let's say you wanted to destroy all the monsters that are on the screen right now. Well, first of all, let's remember that we have these monster flags. When you click object details on a monster, for example, then you click this checkbox. Make sure that it's a monster. Those are what we call object flags. Here it says monster flags, but in the code they're called object flags. Okay, so we're going to be looking at something we haven't talked about yet, so I'm not going to go too much into detail here. But I just wanted to show you how we could use a loop for something. So I'm starting out, like I said, loading X with 0. I create a label, destroy monster loop. So here I'm loading A with object flags. I'm using this AND thing. We haven't talked about that, so let's not go into that now. But basically what is happening here is that I'm checking is for this specific object, is it a monster? Is this checkbox checked for this object? If it's not, then we go to not a monster down here. And then we say increase X by 1, so X goes up by 1. I mean comparing X with total max objects. Now total max objects, that's a NESmaker thing. That's the maximum objects that you can have in a game. I think it's 13 by default. So we're comparing X to that number. And by the way, as you can see, the way it's written here, this is a constant. So we're comparing X to that. Branch if not equal. If we haven't reached this yet, which we haven't, we just went up from 0 to 1, and this is 13. Branch if not equal, destroy monster loop. So we go up here again. And we do the same thing again. So we're checking through all the active objects, one after the other. And for every one, we're checking, is this flag, was this checkbox checked? Is it a monster or not? So if it is a monster, we say, alright, destroy object. And we just continue on. Increase X, compare X, we do it again and again and again. Is it a monster? Yes, no. If it is a monster, destroy it and continue. If it's not a monster, then skip this and continue on to the next one. So that's how we would go through all the active objects. All the objects that are active on the screen right now, and check if they're a monster or not. If they're a monster, we destroy it. Okay, maybe a little bit complex, but we're gonna come back to this AND thing later. Anyway, that was just to show you another example how we can use loops. So that was a lot. I hope you were able to follow along. As you can see, now things are starting to, I don't want to say complicated, but it's a little more complex. Assembly language, like I said, it requires persistence and patience. So you need to be able to, you should really try to practice if you can. Create a test project in NESmaker, play around, maybe look at something we've been talking about in these videos, just play around a little bit. And, you know, speaking from experience, especially now in the beginning, there might be times when you are a little frustrated, stuff like that. So if there's a specific thing you're looking for, you can ask on the NESmaker forum. But Just keep at it and you'll master it. So anyway, that's it for now. Have a great day, and I'll see you in the next video. Bye bye.